Did you know they found out the soul weighs 21 grams? The soul's weight is a popular concept popularized by the film 21 grams. The concept originated from a 1907 experiment by Dr. Duncan McDougall, who claimed to have measured a loss of 21 grams at the moment of death. The weight of a dollar bill is approximately 1 gram. A dollar weighs 1 gram, so a soul weighs $21. It takes 21 days to start a new habit. It takes 21 days to break a habit. 2 and 1 is 3. There's some alchemy going on here. Earth humans pride themselves in the one book of mathematics, which only contains algebra, geometry, probability, mathematical physics, trigonometry, number theory, calculus, combinatorics, differential equation, arithmetic, game theory, topology, information theory, logic, set theory, theory of computation, discrete mathematics, numbers, operations research, advanced math, analysis, and mathematical analysis. Some elites who attend Harvard University who take Math 55 claim this is their top level of math. Math 55 is a highly challenging two-semester freshman-level mathematics course at Harvard University. It's known for its rigorous pace and the depth of the material covered, often described as the hardest undergraduate math class in the country. The course is split into 2 parts. Math 55A studies in algebra and group theory, and Math 55B studies in real and complex analysis. Then there's rocket math, or science. Rocket science is a broad field encompassing the scientific and engineering principles behind designing, building and launching rockets and space vehicles. It's often used as a colloquial term for something complex or difficult to understand. In its technical sense, rocket science involves various disciplines, including aerospace engineering, orbital mechanics, and the chemistry and engineering of rocket propulsion systems. The universe is a vast and mysterious place, stretching far beyond what our eyes can see or our minds can easily comprehend. When we look up at the night sky, we're reminded of just how small we are in the grand scheme of things, and yet how deeply connected we are to everything that exists. For centuries, humans have gazed at the stars and wondered about our place in the cosmos. Across cultures and generations, people have looked upwards, searching for answers to age-old questions. Why are we here? What is our purpose? We crave understanding. We search for meaning, hoping to find our own story written among the stars. And in that search, we often turn to systems of knowledge that help us make sense of the world around us. We seek out wisdom in ancient texts, scientific discoveries, and the collective knowledge passed down through generations. These systems become our guides, helping us navigate the mysteries of existence. Some look to religion, finding comfort and answers in spiritual traditions and sacred stories. Others turn to philosophy, engaging in deep conversations and debates about the nature of reality, ethics, and the human experience. Each path offers its own insights, its own way of interpreting the universe, but there's another language that speaks to the fundamental truths of the universe: mathematics. Unlike spoken languages, mathematics transcends borders and cultures. It is a universal code, a way of describing the patterns and laws that govern everything from the tiniest particles to the largest galaxies. Mathematics isn't just about equations and formulas written on a chalkboard. It's a lens through which we can observe the hidden order in chaos. It allows us to predict, to measure, and to understand phenomena that might otherwise seem random or unknowable. It's a way of seeing patterns, relationships, and connections that underlie the fabric of reality. Whether it's the symmetry of a snowflake, the spiral of a galaxy, or the rhythm of a heartbeat, mathematics reveals the interconnectedness of all things. 5%ers, followers of a system of thought, utilize supreme mathematics as a framework for understanding their relationship with the universe and achieving spiritual enlightenment. They believe this system, which assigns qualitative values to numbers, offers a path to self-discovery and a deeper understanding of the universe's principles. What is supreme mathematics? It's a system of numerology that assigns symbolic meanings to numbers beyond their numerical value. For instance, the number 1 is associated with knowledge, 2 with wisdom, and so on. Why do 5%ers use it? They see it as a tool for interpreting the world around them and understanding their own place in it. By understanding the symbolic meanings of numbers, they believe they can gain insights into their own nature and the nature of reality. 5%ers also utilize a supreme alphabet, which, like supreme mathematics, assigns qualitative values to letters. These two systems are interwoven and are seen as essential tools for interpreting the world as a spiritual text. The supreme mathematics and supreme alphabet are key concepts in the 5% nation. The supreme mathematics is a system of understanding numerals alongside concepts and qualitative representations that are used along with the supreme alphabet. The supreme mathematics is thought to be the highest system of numerology in the NGE, used to give qualitative value to numbers in addition to quantity. How the values associated with each number were derived is unknown. The numerals are as follows: 1. Knowledge 2. Wisdom 3. Understanding 4. Culture or freedom 5. Power or refinement 6. Equality 7. The all 8. Build or destroy 9. Born, birth 0. Cipher. The supreme alphabet is a system of interpreting text and finding deeper meaning from the Nation of Islam lessons by assigning actual meanings to the letters of the Latin script. For example, the first letter A stands for Allah, B stand for be or born, C stand for see, D stand for divine, E stand for equality, F stand for father, G stand for God, H stand for he or her, I stand for I or Islam. J stand for justice, K stand for king or kingdom, the 12th letter L stands for love, hell or right, and the 13th letter M stands for master. N stand for in or now nation, O stand for cipher, P stand for power, Q stand for queen, R stand for rule or ruler, S stand for self, savior, T stand for truth or square, U stand for you, universe, and UNI verse, V stand for victory, W stand for wisdom, woman, X stand for unknown, Y stand for why, and Z stand for zigzag zig. The supreme alphabet was developed by Allah the Father and Justice, also known as Clarence 13X. The method by which letters were associated with certain values is unknown. This is all Tahuti's alchemy. From the smallest atom to the largest galaxy, the universe operates according to mathematical principles. These principles are woven into the very structure of existence, shaping the way matter moves, energy flows, and life evolves. To understand these principles is to gain a deeper appreciation for the elegance and complexity of the cosmos. It's as if the universe is a grand puzzle, and mathematics provides us with the clues to unlock its secrets. The more we learn, the more we realize how much there is yet to discover. In the words of Galileo Galilei, mathematics is the language in which the All has written the universe. This idea suggests that if we can learn to read this language, we can begin to understand the mind of the cosmos itself. But what if we could take this idea a step further? What if mathematics isn't just a tool for scientists and philosophers, but a key to understanding ourselves and our place in the universe on a personal level? What if numbers themselves held deeper meanings, unlocking secrets about us and the universe? Imagine if every number, every equation carried a message, a lesson about life, growth, and the nature of reality. This is the central idea behind supreme mathematics, a system of knowledge embraced by the 5%ers. Supreme mathematics invites us to see numbers not just as quantities, but as symbols rich with meaning, offering new ways to interpret our experiences and the world around us. Through this lens, numbers become a bridge between the physical and the spiritual, the known and the unknown, guiding us toward greater wisdom and self-awareness. Imagine a library. Not just any library, but the universe's grandest. This library holds the secrets of the cosmos, penned in 999 books of pure mathematics. Each equation, each theorem, a key to unlocking reality's deepest mysteries. Now imagine that our planet Earth possesses just one of these books. One book out of 999. It makes you feel quite small, doesn't it? This single book, passed down through generations, has brought us a long way. We've used it to understand our world, to build incredible things, to even venture into space. But what about the other 998 books? What wonders do they contain? What secrets of the universe are locked within their pages, waiting to be discovered? Imagine walking through this cosmic library, each book a gateway to a different aspect of the universe. The knowledge contained within these books could revolutionize our understanding of existence. Scientists and researchers have only begun to scratch the surface of what our single book holds. The curiosity that drives us to look up at the stars, to ask questions, to seek answers, is the same curiosity that will one day unlock the other books. Imagine the advancements we could achieve with just one more book, let alone all 998. The future generations, inspired by the mysteries of the cosmos, will continue this quest for knowledge. It will take the collective effort of humanity, working together to unlock these cosmic secrets. Each book, a beacon of light, guiding us towards a deeper understanding of the universe. The cosmic library awaits, filled with knowledge, wonder, and the promise of endless discovery. Are you ready to turn the page and explore the unknown? To grasp the sheer scale of this cosmic library, we must journey outwards into the vast expanse of the universe. Light, the fastest thing we know, becomes our cosmic yardstick. Traveling at an incredible 186,282 miles per second, it takes light a year to cover a distance we call a light year. Our universe, in its continual expansion, currently stretches over 96 billion light-years. That's 96 billion times the distance of light. The fastest thing in the universe travels in 1 year. Within this unimaginable vastness, 999 books hold the keys to the cosmos, and we, on our little blue planet, hold just one. Alnitak, Zeta Orionis, the easternmost star in Orion's belt, is a triple star system approximately 1,260 light-years from Earth. The primary star, Alnitak A, is a blue supergiant and the brightest class O star in the night sky. Alnilam, Epsilon Orionis, the central star, is a blue supergiant around 2,000 light-years away. Sirius, the brightest star in the night sky, is located approximately 8.6 light-years away from Earth. This means it takes light about 8.6 years to travel from Sirius to our planet. It would take approximately 1.07710 circumflex 18 years to cover that distance. It would take approximately 99.5 days to travel to the Moon at 100 miles per hour. This is based on the average distance of the Moon from Earth, which is 238,855 miles. Also, sound travels at the rate of 1,120 feet per second. Sound travels through air at approximately 0.21 miles per second, or roughly 750 miles per hour. This means it takes about 5 seconds for sound to travel 1 mile. The speed of sound is also influenced by temperature and the medium through which it travels, with sound generally traveling faster in liquids and solids than in air. It would take an extraordinarily long time to reach the Orion constellation at 100 miles per hour. The distance to the Orion constellation is so vast that even at that speed it would take hundreds of thousands of years to reach it. To navigate these cosmic distances, we need a measuring stick grander than what we use here on Earth. We need the metric system, a system built for the universe. Forget inches and ounces, we're talking kilometers and tons, megatons, gigatons. Take the kiloton, for example. 1 kiloton is equivalent to 1,000 tons of TNT. It's the kind of energy we use to measure the destructive force of the universe's most powerful events. And yet, even kilotons seem minuscule when we talk about the energy output of stars or the forces that bind galaxies together. The primary force that binds galaxies together is gravity. This mutual attraction between all the objects within a galaxy, including stars, gas, dust, and dark matter, keeps them bound together, preventing them from drifting apart. Dark matter, though invisible, also contributes significantly to the gravitational force needed to hold galaxies together. Gravity is Big Mama's hands. From a cosmic perspective, Earth is but a tiny blue dot suspended in the vastness of space. A mere 93 million miles from the Sun, our planet basks in the warm glow of our nearest star. We call this distance an astronomical unit, or AU, a convenient way to measure the vast distances between planets within our solar system. To put this distance into perspective, consider this. It takes light from the Sun about 8 minutes to reach Earth. That means that if the Sun were to suddenly disappear, don't worry, it won't, we wouldn't even know it for a whole 8 minutes. Mercury is 0.39 AU, 36 million miles, 58 million kilometers from the Sun. Venus is 0.72 AU, 67.2 million miles, 108 million kilometers from the Sun. Earth is 1.00 AU, 93 million miles, 150 million kilometers from the Sun. Mars is 1.52 AU, 141.6 million miles, 228 million kilometers from the Sun. Jupiter is 5.20 AU, 483.8 million miles, 778 million kilometers. Saturn is 9.54 AU, 889.8 million miles, 1.4 billion kilometers. Uranus is 19.20 AU, 1.8 billion miles, 2.9 billion kilometers. Neptune is 30.06 AU, 2.8 billion miles, 4.5 billion kilometers. Pluto is 49.48 AU, 4.6 billion miles away, 7.4 billion kilometers. It takes sunlight approximately 5.5 hours to travel from the Sun to Pluto. This is because Pluto is an average of 3.67 billion miles, 5.9 billion kilometers, away from the Sun. It takes sunlight approximately 3.2 minutes to travel from the Sun to Mercury. This is because Mercury is the closest planet to the Sun, with an average distance of about 35 million miles, 58 million kilometers, or 0.387 AU. The dance of land and water. Our little blue dot Earth is a vibrant world where land and water are in a constant state of motion and interaction. This dynamic interplay shapes the very essence of our planet. The total area of the land and water of the planet Earth is 196,940,000 square miles. The circumference of the planet Earth is 24,896 miles. The diameter of the Earth is 7,926 miles. The area of the land is 57,255,000 square miles. The area of the water is 139,685,000 square miles. The Pacific Ocean covers 68,634,000 square miles. The Atlantic Ocean covers 41,321,000 square miles. The Indian Ocean covers 29,430,000 square miles. The lakes and rivers cover 1 million square miles. The hills and mountains cover 14 million square miles. The islands are 1,910,000 square miles. The deserts are 4,861,000 square miles. Mount Everest is 29,141 feet high. The producing land is 29 million square miles. The Earth weighs 6 sextillion tons, a unit followed by 21 ciphers. The Earth is 93 million miles from the Sun. About 71% of Earth's surface is covered in liquid water, a vast expanse that includes oceans, seas, rivers, and lakes. This abundance of water is what makes Earth so unique and teeming with life. This fact alone sets our planet apart in the known universe, as no other planet we have discovered so far has such a significant amount of liquid water on its surface. The remaining 29% of Earth's surface is land, a diverse patchwork of continents and islands. These land masses are not static. They are constantly shifting and changing over millions of years due to the movement of tectonic plates. This process, known as continental drift, has shaped the geography of our planet, creating mountains, valleys, and other landforms. Islands emerge and disappear, coastlines change, and the face of Earth is continually being reshaped. Earth spins on its axis at a rate of about 1,000 miles per hour, a rotation that gives us the cycle of day and night. This rotation is crucial for the regulation of our planet's climate and weather patterns. As the Earth rotates, we experience the beautiful transitions of sunrise and sunset, marking the passage of time and the rhythm of life on our planet. At the same time, Earth is hurtling through space at an astonishing 67,000 miles per hour, orbiting the Sun. This orbit is not a perfect circle, but an elliptical path that brings us closer to and farther from the Sun at different times of the year. Mars is a little slower and farther from the Sun, so a full circuit takes 687 Earth days, or 1 Mars year. That longer year means longer seasons too. A year on Saturn takes approximately 10,759 Earth days, or roughly 29.4 Earth years. This is the time it takes for Saturn to complete one full orbit around the Sun. A year on Mercury is about 88 Earth days long. Mercury has the shortest year of any planet in the solar system. A year on Neptune, which is the time it takes for the planet to complete one orbit around the Sun, is approximately 60,190 Earth days, or about 164.8 Earth years. A year on Uranus, which is defined by the time it takes for the planet to orbit the Sun, lasts for approximately 84 Earth years. This equates to roughly 30,687 Earth days. A year on Pluto, which is defined by the time it takes to orbit the Sun once, is equivalent to 248 Earth years, or 90,560 Earth days. In other words, Pluto takes approximately 248 Earth years to complete one orbit around the Sun. A year on Jupiter takes approximately 4,333 Earth days. This is equivalent to about 11.86 Earth years. This delicate dance between our planet, our star, and the vastness of space is a testament to the intricate laws of physics that govern our universe. The gravitational pull of the Sun keeps Earth in its orbit, while the tilt of our planet's axis gives us the changing seasons. These seasonal changes affect everything from the weather to the behavior of plants and animals, creating a dynamic and ever-changing environment. The interplay of land and water, the rotation of Earth, and its orbit around the Sun all contribute to the complex and beautiful dance of life on our planet. From the lush rainforests to the arid deserts, from the icy poles to the temperate forests, every part of Earth is a testament to the incredible diversity and resilience of life. This dance of land and water, guided by the forces of nature, continues to shape our world in ways we are only beginning to understand. As we look at our planet from space, we are reminded of the delicate balance that sustains life on Earth. The dance of land and water is a beautiful and intricate performance, one that we must cherish and protect for future generations. Binary, the language of the universe. To understand the universe's language, we must turn to a language far simpler than our own binary code. Composed of only two digits, 0 and 1, binary code forms the backbone of the digital world. Every click, every swipe, every calculation made by our computers relies on this simple system. But binary code is more than just a tool for computers, it's the language of the universe itself. At the most fundamental level, the universe operates on a series of yes, no, on-off switches, represented by the ones and zeros of binary code. Light years and sound barriers. We've talked about light years, but what about sound? Sound, unlike light, needs a medium to travel. It can't travel through the vacuum of space. Here on Earth, sound travels at a relatively pedestrian 767 miles per hour. This means that while light from the Sun reaches us in just 8 minutes, the sound of a supernova, if it could travel through space, would take thousands, even millions of years to reach our ears. A glimpse into the abyss. Looking up at the night sky, we see a tapestry of stars, each a distant sun, many far larger and more powerful than our own. Take Alnitak, a blue supergiant star in Orion's belt, located roughly 736 light-years from Earth. Or Sirius, the brightest star in our night sky, a mere 8.6 light-years away. These distances are staggering, reminding us of the sheer scale and grandeur of the universe. Each star we see represents a potential solar system, perhaps even harboring life on distant planets. Wormholes, shortcuts through space and time. The vast distances between stars and galaxies pose a significant challenge for space exploration. The universe is unimaginably vast. With distances so great that they are measured in light years, the distance light travels in 1 year. Even travelling at the speed of light, which is about 299,792 kilometers per second, it would take thousands of years to reach even the closest star systems. For instance, Proxima Centauri, the nearest star to our solar system, is over 4 light-years away. This is where the concept of wormholes comes into play. Wormholes are fascinating theoretical constructs that could revolutionize our understanding of space travel. Wormholes, theoretical tunnels through space-time, could potentially allow us to bypass the limitations of traditional space travel. They are like shortcuts, connecting two distant points in the universe through a tunnel-like structure. Imagine folding a piece of paper in half and poking a hole through it. This simple analogy helps us visualize how a wormhole might work. That's a simplified analogy for how a wormhole might connect two distant points in space-time, allowing for near instantaneous travel between them. Instead of traveling the long distance across the paper, you simply go through the hole. However, wormholes remain purely theoretical, and their existence is still debated among physicists. The equations of general relativity suggest they could exist, but we have yet to find any empirical evidence. Even if they do exist, harnessing their power for interstellar travel is a challenge far beyond our current technological capabilities. The energy required to create and stabilize a wormhole would be immense, and we currently have no means of generating or controlling such energy. Despite these challenges, the idea of wormholes continues to captivate scientists and the public alike. They represent the tantalizing possibility of exploring distant worlds and galaxies, making the dream of interstellar travel a reality. As our understanding of the universe deepens, who knows what future discoveries await? Perhaps one day wormholes will move from the realm of theory to practical application, opening up new frontiers in space exploration. Until then, the concept of wormholes remains one of the most intriguing and speculative ideas in modern physics, a testament to human curiosity and our desire to explore the unknown.